welcome to FinextraTV. I'm Hannah Wallace, and today I'm kindly joined by David Brimley, Financial Services Industry Consultant for Hazelcast. Hello David, thank you very much for joining us.
Hello, it's a pleasure to be here.
So we're going to be talking about machine learning and streaming data, but before we do, to sort of set the scene for us, could you tell us a bit about yourself and what Hazelcast does?
Sure. I've been in the IT industry now for 30 years. I started out as a programmer working in the early noughties where we had the Web 2.0 boom. I then moved into investment banking and that's really where my interest in distributed systems took off. The front office trading system is always quite an exciting place for computer scientists to work with algorithmic trading, clustering and distributed computing. So this is where I spent a large portion of my career, was working in that area on trading systems. And then after that, the in-memory computing and platform trends came along, the software vendors came along with those solutions. And whilst I was working at those banks, this is where I came into contact with these pieces of software. And then since then, I moved to actually consult and work with these software companies and help financial institutions work with in-memory technology. And that leads me on to Hazelcast. Hazelcast was not the first technology I worked with, but it was certainly one of the most interesting. Hazelcast itself is an open source project that provides in-memory streaming, compute and storage. It's been around now for just about 10 years and it can count amongst its customers most of the leading investment banks, most of the leading retail banks, and it provides transaction processing to most of the major card processors as well. So across the different sectors of finance, Hazelcast and in-memory technology is being used quite widely.
And where are we with machine learning as a whole then, looking over the industry?
So machine learning isn't something that's new. It seems to be the hot new thing, but machine learning actually in the finance industry, in its more naive forms, has been around since the early 90s and even before that. We saw the first elements of that really with some fraud detection, that we had some very basic fraud detection for banks. And certainly, as is the way with these things, the investment banks and trading systems are always at the forefront of a lot of this technology. So we've seen the investment banks and the trading systems adopt machine learning, especially around risk, especially around algorithmic trading as well. They were the early adopters of machine learning. But since then, it's really moved out of the front office. It's moved into the wider area of finance. We're seeing, certainly my own position where I talk to clients on behalf of Hazelcast, we're seeing machine learning being adopted in retail areas as well, so retail banking. So as an example of that, there's fraud detection for retail banking. I've noticed myself personally that when I do an online transaction now, or I phone someone up and provide a card payment, I very rarely, or a decreasing amount, I get the call from the security department asking me to verify that this transaction was, actually valid. And that's all a result of the new machine learning algorithms that we have. So that's coming along there. There is still a lot of work to do in that area though. A lot of studies have found that the problem with this fraud detection is that there's a lot of false positives. So whilst it's very successful at detecting the actual fraud, it also puts a lot of false positives out there as well. So that's very, very bad for the user experience still. So that's where we're going with machine learning at the moment. And also really around user experience, there's a lot of machine learning being used to improve user experience of retail banking as well. So things like chatbots, there's a lot of chatbots. People don't, banks are trying to, it almost seems as if they don't want you to talk to anyone, so they'd much rather have you with a chatbot.
Sadly feels like that sometimes.
Yes, it is frustrating sometimes you want to talk to a human, but now if you try to talk to some of these chatbots, they're actually quite good, and they're actually becoming more integrated with the accounting systems as well. So you can actually talk to a chatbot. They will know about your account and you can deal with them. And they'll be able to answer a lot of your questions. Yeah,
it's certainly been my experience. So you've highlighted there some of the advantages and the disadvantages with machine learning. But what do you think financial services firms need to really consider as they progress through their machine learning journey?
Well, there are a number of things, and there's never a free lunch with any technology. The first problem you've got is that the actual software industry around machine learning can be quite complicated. It's quite fragmented. There are a lot of different vendors that are sticking ML onto their software and saying that, this is the solution for you. So IT departments in financial institutions are going to have to spend a lot of time thinking about their ML strategy, thinking about the vendors that they deal with. So that's one part of the problem. The second part of the problem is that any machine learning or any artificial intelligence is only as good as the data that you feed it. So whilst we do have very, very good models now for things like predictive analysis and other things, it's the actual data that is the thing. That's the golden thing
data
that you need.
Data is key.
Exactly. And financial organisations, all organisations always struggle with trying to bring all of their data together, try to find the best data. It's always, this is the one reason why I've had a career in IT for 25 years is just the data and bringing that data together. So that is the real problem. So first of all, look at your data, try to work out ways to, curate that data correctly. And then you'll have a good experience from machine learning. On the flip side, I've seen people pump masses of data from, we have these huge data lakes now that a lot of organisations have, and a lot of it is not really very valuable for machine learning. So that's where your real expenditure will be in the data curation.
Well, that feeds me quite nicely into my next question on the topic of streaming data. How can financial services firms go through streaming data without having to go through a complete re-architecture of their systems?
So if you look at how financial institutions deal with data, it's always, as the businesses move forward and we have things like the open banking APIs, people with mobile devices, the way in which these institutions have to deal with data has changed. We've moved away from the old paradigm of data coming in, it being stored somewhere and it being processed at a later date, the traditional batch processing systems. And people nowadays want an instant data experience. So this is really where data and streaming data platforms come into play. You'll have seen that the challenger banks in particular have been very, very successful in the way that they've been able to develop new apps and new functionality for their customers. And that's really because they've embraced streaming data and streaming platforms at the heart of their systems. They've made it core to the way that they deal with their data. So then this, of course, presents a challenge to the traditional banks and the traditional institutions who have maybe some mainframes, some old relational databases, lots of different places where this data is stored. And as I said, it's the old store and then process approach rather than the process and store approach of streaming. But there are technologies that these banks can start to introduce streaming into their flows. There's a particular technology called change data capture. And this is basically a process that looks at the old legacy data stores. It watches those legacy data stores for updates, and it turns those updates into streams of data so that you can then start to build streaming systems on top of your legacy data stores.
So you've certainly painted the picture and shown us where we are today, but looking ahead, what trends are we likely to see evolve, and what should financial technologists be keeping an eye on?
Right. Well, there are three big trends. I mean, obviously, there's the cloud, and we can talk about that later. But there's the in-memory computing trend, and this is something that Hazelcast is really at the forefront of. This is where we start to talk about having all of your data in one place, so not in the mainframe, not in the database, not in any other data stores. In-memory technology like Hazelcast enables you to bring together all of these legacy data stores, have them in memory. And so having them in memory gives you that very, very fast processing that you need. So that's a future trend, is definitely the in-memory compute and storage trends. And the interesting part about that, and really the reasons why we need to move to that place, is there was a survey that Hazelcast did about 6 months ago where we asked industry practitioners how did they measure latency in their systems and how important was latency in their systems. Because this is something that's very, very important with streaming, right? And you have a stream of data. You need to process that data as quickly as you can, to not only beat the other guy, but to give you a competitive advantage. And we found that actually a lot of people, when they're measuring their systems, they still measure their systems in seconds. Some of them measure their systems in milliseconds of latency, but even milliseconds is very, very slow in today's systems. So today you really need to start thinking about microseconds and how you measure your systems and how they process. And this is where in-memory comes in. You generally can't have systems with relational or mainframes or any of these other legacy stores and compute platforms to give you latency in microseconds. So this is where you'll see a trend moving towards in-memory. And so there's the two advantages: there's the speed, and then there's the amalgamation of all of the data. Mm-hmm. Now, why do microseconds count? Because, you know, a blink of an eye isn't a microsecond; it's a lot slower than that. Well, it counts in things like fraud detection. Yeah. Now, if you're doing a credit card swipe or any kind of retail transaction, the time of that transaction is spent really transferring the data from the terminal all the way over the network, over the internet maybe, to some kind of data center somewhere. That then only gives the data center and the computer that's making the decision about the fraud a few microseconds. That's the window that you get before you have to return back the answer. Okay, so if you can slice off even a few microseconds off of that processing time, that's 100% maybe increase or 1,000% increase in the amount of processing time you still have then. So what you can do with that time saving is, if you think you've given yourself an extra 1,000% of processing time, you could then start to introduce even more complex and intricate fraud detection algorithms. So this is then how we can start to be much better about getting rid of the false positives out of our fraud detection. And any other thing that you can think of that you can save that time. So microseconds really do count in today's world. So that's the in-memory platforms that Hazelcast are very successful at, with the in-memory storage, the in-memory streaming. And then we move over to the cloud, and obviously it's on everyone's lips, everyone's moving to the cloud. You need to also then start to pick platforms that can go to the cloud. So again, we talk about legacy data systems, legacy mainframes, even relational databases, and even some of today's streaming technologies will have difficulty moving to the cloud. Mm-hmm. So again, this is something that with Hazelcast, we've been very, very careful to produce a product that can move to the cloud successfully. And then lastly, when you're thinking about your cloud journey, always think about your portability between cloud vendors. So this is where containerization comes into play. It gives you, there's certain technical products called Kubernetes and Docker. Kubernetes is a technology that will give you an abstraction layer over your cloud vendor, so that you can then move your systems from cloud vendor to cloud vendor without becoming locked into them.
Some really exciting developments ahead.
Yes.
Then. You're doing some really interesting stuff at Hazelcast.
Yes.
Well, David, thank you so much for coming and sharing your insights today. It's been a pleasure.
Thanks a lot. Thank you.